Welcome to SciTech Culture with Steve Kern and Ben Warner, where we examine science, technology and culture in the 21st century. Visit our website at scitechculture.com.
Can't believe it. It seems we're going to have like a RAM shortage. Well, not so much a RAM shortage, it's more that RAM is going to cost a lot more. And again, we come back to our usual topic du jour of the year, Steve, in AI may be the culprit of this as well, because, obviously there's been a lot of discussion around AI and its power needs, so to speak, and more data centers required. Obviously, data centers are just effectively a whole bunch of computers with chips in them that and storage that need a lot of electricity and power, and they also need the right chips in them as well, and obviously they need RAM to run them as well. And it would appear that a lot of the RAM market, and it's a bit hard to imagine maybe that in a global market of chips that these tech companies that are creating data centers are sucking up so many of them that it's actually leading to increased costs for just the average Joe wanting to put a couple of extra bits of RAM into their PC or Mac or whatever. And I just found that interesting. It's just and then of course there's this also other angle of like talked about what happens if the bottom falls out a bit under the AI hype bubble, and all of a sudden all of these chips that they bought, whether or not they're still going to be used for the purposes that they need to be, is that still going to have an impact on the market because they sucked up so much of the market in purchasing them all that it still might take several years before RAM for everyday appliances and computers and whatever that we use will become available at a reasonable price. It's not looking good from what it would seem.
Well, yeah, look, I don't really understand much about the chip market but I do understand supply and demand, and what we're seeing here off the back of AI enthusiasm is a projection of how many data centers are needed. I haven't seen anywhere that actually those many data centers are needed, just that they're projected that we will need them if everything comes true by 2030. And I think we were saying last week that for that to occur, everyone would have to be willing to spend 30 times more on their current software licensing than they are now in the next 5 years, which I'm not sure is the case. That aside, you start making those chips because you assume there's demand, and I guess you don't make chips that aren't going to sell as well, and that includes the gaming chips. So I really don't know what this means, and I don't know if these chips rapidly go out of date. So if the data centers aren't built in the next 2 or 3 years, what do you do with a 3-year-old chip? Is it still as good as it could be? I assume NVIDIA never stops its development cycle. I'm assuming none of the chip manufacturers ever stop their development cycle. So, yeah, I wonder if you could build the data centers instantly, or the data centers were already there, maybe it would make sense. But we seem to be tooling up for data centers that are projected to be needed. And yeah, I don't know what happens. I hope they use all those chips.
Absolutely. You wouldn't want them to go to waste, for sure. I mean, the other thing that sort of occurred to me was this idea of sustainability. And to take a step back from that to start with, it's the idea that instead of looking for, say, a more efficient or a smarter way of going about this, the approach seems to be the age-old, we'll just scale up, just make more, just do more, spend more, create more, as opposed to, can we do this in a way that's smarter, in terms of what we're doing. Obviously that's a big question, because that could mean looking fundamentally at how these data centers are built to be to take that into account, and also what hardware is available, like in this case RAM chips or whatever, how that can be sustained, for everyone, I guess, who wants them, as opposed to just a select few that are maybe monopolizing the supply. and it just doesn't seem to have gone in the direction. It's just scale up, just do more. Well, we can always produce more, you know.
Well, yeah, and I think, if you look at the way NVIDIA's been talking, well, of course, they probably don't want any improvements to data centers at this stage because they want to sell more chips. They have to sell more chips, and they are selling more chips. But you're absolutely right. And there's no question over the next 5 years as we start to build all these necessary data centers that people are going to develop better ways, better architectures, better systems to deliver these data centers. And what if they manage to work out a way to reduce the requirement for chips by 20%?
That wouldn't affect anyone's interests, I'm sure.
No, definitely not.
Absolutely. All right, we might keep an eye on that one. Obviously, we're recording this through the Black Friday sales weekend. Get your sales in now. Maybe there won't be chips around later at some point. Who knows? But you'll be fine, I think, as far as that's concerned. But it just makes it funny, like this. It's almost like an overconsumption of all this stuff. And it would just be nice if there was a bit, like I said, a smarter way to go about figuring some of this stuff out.
Well, that's right. But this is what when you get a bubble or over exuberance, these are the sorts of things you see the real world implications of AI enthusiasm.
Yes, indeed. Okay, so we're going to just talk about a few science topics now, or more outer space topics, for lack of a better term. I actually had this topic on the list for a while. We deferred it for some more AI discussion, but now we can talk about it because it was in the news about a month ago. I think this idea the Hubble tension is becoming a Hubble crisis, which obviously this article from Scientific American goes into great detail about it, but essentially it was, and correct me if I'm wrong if I've misunderstood this, it's the idea of there's two precise measurements, or two different ways that can generate two different precise measurements on the expansion rate of the universe. And they generate two different numbers. And obviously this is a cause for concern because there might be something that is missing. Something's not right with the, potentially what we're measuring and what we're looking at. It could be that there might be a way that the way these measurements are done, maybe there's something not right there, or more likely there might be something we're just missing from our understanding of how this is done, or our understanding of the universe, etc. Like I think it says later in the article that there's something in physics that we're not quite grasping that could explain those two different things. As we know, the universe and the way it works doesn't quite. How would you put it? It doesn't really fit with the way our human senses tend to take the world in. So it's completely plausible. Like for instance, that you could have two different numbers, and it makes perfect sense that that's the way it is.
Well, potentially that could be the quantum, aspect of the universe. I think what's interesting is that the rate of expansion of the universe is theoretically dependent on the amount of dark energy, dark matter, and real matter, and those proportions interacting in ways that I can't explain drive the expansion or control the expansion rate of the universe. And from this article, it appears that there are two different techniques to measure what you would expect in terms of that expansion, which should be able to get you back to a constant, which is the exact rate that the universe is expanding by. But these two techniques give two totally different answers. So I just, what else can we say? For physicists, this is really quite serious because, you can't make a calculation with two different numbers, and it's not a matter of just averaging them out. One of them's more correct than the other, but which one, why, how? So this is why it's become a Hubble crisis. So it's quite interesting. It's very interesting that we have these techniques that can so accurately measure the expansion rate of the universe. But it's really interesting that we don't really understand what's behind it or how it's driven. And because of that, our measurements, we get two different measurements, and we're none the wiser as to which measurement we should go with. But I guess that's theoretical physics for you.
Absolutely.
Or cosmology in this case.
And I always go back to the thinking that there's so much that it could be just a matter of, and I'd say this in a more way that would be measurable, of course, but the idea that it's a perspective, that the way we're looking at it could also be in there as well. So obviously, when I say that, I don't mean that in a philosophical way or anything. I mean in a way that physicists would actually calculate this thing. That there might be just
a reference frame, for instance. Yeah.
Yeah. So, and it might be just something that's missing. And usually, if you go back into the history of how these things are discovered, eventually someone works it out in terms of that. But then it might also lead to a whole series of other questions that go down another rabbit hole of, there's all this other stuff now that's open to us to explore.
Oh, absolutely. And look, while this is a very important question for physics, it's not going to have a lot of impact on us. It's not as if we're trying to get to the other end of the universe and need to know exactly what that constant is so we can program the flight computer.
That's exactly. Nothing's going to change for us while they're trying to work it out.
Yeah, that's right. But I hope they do work it out. Keep working on it, all you physicists.
Absolutely.
Don't stop.
No, we don't. We certainly don't want them to stop, because otherwise we'd be in blissful ignorance so far with everything that has come out.
That's right. The truth is out there.
Absolutely. Well, speaking of that, if we go to Mars, I did like this story about NASA's Perseverance rover capturing sounds of lightning on Mars for the first time, although obviously it's not in the form of what we would call lightning and thunder as we would know it. But this would make sense, wouldn't it? I know that Mars's atmosphere is obviously a lot thinner, etc., but there'd be enough there to generate effects, I guess would be the way to put it.
Well, I just want to start by, I'm puzzled by the title. I really thought lightning had no sound. But, so are they talking about, what, Martian thunder? I don't know. Anyway, so very interestingly, the Martian atmosphere is much, much less dense than the Earth's. It's only, I think, about 1% the density. And because of that, it means that the air on Mars is really thin, and you can have winds, believe it or not, up to 1,000 kilometers an hour on Mars. But we would be able to stand up in those 1,000 kilometer an hour winds because their atmosphere is so thin. So I find that amazing on its own. But then what happens on Mars, because there's no free water in the atmosphere, or not very much in the atmosphere at all, it's actually the dust particles that become charged and create electricity, which then zaps with lightning in their little whirlies. So there you go. And that's what apparently the rover experienced.
Absolutely. And then another good reason to have rovers on these things, to be able to pick these things up and give us some additional perspective. I feel like I've gotten homework now. I should go onto the feedback forum for the ABC side just to give them the definition of lightning and thunder now.
I'm sure, I haven't been myself, but I'll be surprised if there isn't 10,000 comments arguing about that. But anyway.
Absolutely. All right, Steve, we might wrap it up there. All very interesting. I'll have to go check what the RAM prices are like. Not that I need to go too far with it, but it might depend. It might be an interesting rabbit hole to see what types of prices are for computer parts these days.
Maybe we can take a leaf out of Steve Jobs' book and start building data centers in our carports or something like that.
All self-sustained. Yes, absolutely.
and then sell them.
Yeah, that's right. Sell the excess capacity. Yeah, absolutely.
Home data centers.
Absolutely. Alrighty, so that's it for this week's episode. We'll catch you next time.